In section 2-1, we're going to understand set concepts. In this section, what you will learn is how to determine the quality of sets and the inequality of sets, know the application of sets, know what are the infinite sets and finite sets. A set is a collection of objects which are called elements or members of the set. Three methods of indicating a set: description, the set of the month of the year, roster form, A equals bracket 1, 2, 3, 4, epsilon, that is ... bracket. Set builder notation is A is equal to the set of X such that X belongs to the natural numbers. So in this case, this symbol means such that X belongs, there's the belong symbol, and the natural number set is this. A set is well defined if its contents can be clearly defined. An example is the set of U.S. presidents is a well-defined set. It contains the presidents that can be named. So we want to be able to write a description of the sets containing the elements Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. The description of the set, solution set, is the set is the days of the week. That's the description. In roster form, listing the elements of a set inside a pair of braces or brackets is called roster form. The example is braces, open braces, 1, 2, 3 is the notation for the set of whose elements are 1, 2, and 3. Parentheses 1, 2, and 3 and the other bracket 1, 2, or 3 are not sets. Sets are generally named with capital letters. The definition of the natural numbers. The set of natural numbers or counting numbers is n. So n is the set of the natural or counting numbers. In this case, it's a brace 1, 2, 3, 4, 5, ... which means the pattern goes on forever. Brackets closed. Express the following in roster form. A set A is the set of natural numbers less than 6. So our solution is A is equal to 1, 2, 3, 4, 5 enclosed in braces. Express the following in roster form. Set B is the set of natural numbers less than or equal to 80. Here we have B, capital B, is equal to the braces 1, 2, 3, 4, ... comma 80. Here the ... is the pattern in between 4 and 80. Express the following in roster form. Set P is the set of planets in Earth's solar system. There we have a description. And now our solution is capital P equals Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. In this case, we haven't decided Pluto belongs in the solar system. The symbol, this symbol here, which looks like an E, reads is an element of, is used to indicate the membership of a set. The symbol with the E kind of with a slash through it means is not an element of. So in set builder notation, a formal statement that describes the members of a set is written between the braces. A variable may represent any one of the members of the set and usually is a variable. So, using set builder notation, we write the set B is equal to 1, 2, 3, 4, 5 in set builder notation. We write the words and how you would read set B in set builder notation. So here is the notation where we have the braces X, and then we have a line, and then we have X and the belongs symbol N and X less than 6, or we have B equals to X with the same line, X belonging to N and X less than or equal to 5. So the way we read it is the set of all X such that, this is the such that statement, is a natural number and X is less than 6. So now we can go between different forms. We're going to write the set A equals X such that X belongs to the natural number set and X is between 2, which equals 2, and less than 8. The solution in roster form is A is equal to 2, 3, 4, 5, 6, and 7. Notice we can go in between both the set builder and the roster form. We can go between the two. So a finite set is a set that contains no elements, or the number of elements in the set is a natural number. For example, set B equals 2, 4, 6, 8, 10 is a finite set because the numbers of the elements in the set of 5, and the 5 is a natural number. In other words, finite means there's only a countable number of members in the set. A set that is not finite is said to be infinite. In other words, we couldn't count the numbers in the set. So the set of counting numbers is an example of an infinite set. A set A is equal to set B, symbolized by A equals B, if and only if set A and set B contain exactly the same members. In other words, 1, 2, 3 equals 3, 1, 2. The members are the same, they don't have to be in the same order. The cardinal number of a set A, symbolized by small n parentheses A, is the number of elements in set A. Example, here we have A is equal to 1, 2, 3, and B is equal to England, Brazil, Japan. Both have the same number, cardinal number 3. So n of A equals 3, and n of B is equal to 3. Set A is equivalent to set B if and only if the cardinal number n of A is equal to the cardinal number of B. So an example is here we have the set A, B, C, and we have the set apple, orange, and pear. Notice that D, the cardinal number of D, is equal to the cardinal number of E, which is 3. So set A, or in this case set D, is equivalent to set E. So in this particular case, equivalence doesn't mean equal. However, any sets that are equal must be equivalent. Not all sets are equivalent are equal. Example again, D, which is A, B, and C, and E, which is apples, orange, or pear, are equivalent, but they are not equal. One-to-one correspondence. Set A and set B can be placed in one-to-one correspondence if every element of set A can be matched with exactly one element of set B, and every element of set B can be matched with exactly one element of set A. Consider the set S states and the set C state capitals. Here S is North Carolina, Georgia, South Carolina, and Florida. Set C is Columbia, Raleigh, Tallahassee, and Atlanta. Two different one-to-one correspondence for sets S and C are, we could draw the one-to-one correspondence since each one of the units is equal to, in S, is equal to each of the members in C. Obviously, these are not the right correspondence. We have the right ones in the second case. North Carolina has the state capital Raleigh. Georgia has the capital Atlanta. South Carolina has the capital Columbia. And Florida has the capital Tallahassee. Again, it's one-to-one correspondence. Another one-to-one correspondence between set S and set C are possible. Do you know which capital goes with which state? Actually, it was the second one which was true. The sets that contain no elements is called an empty set or the null set and is symbolized by an empty set of brackets or a big zero with a line through it. Note that we cannot symbolize the empty set in this way where we have the zero with a slash in it. This contains the element actual 0 and has a cardinality of 1. The set of 0 is also noted not the empty set because it contains the element 0. It has a cardinality of 1. So anytime there's a member inside the bracket, it's not empty. The universal set, symbolized by U, contains all the elements for any specific discussion. When the universal set is given, only the elements in universal set may be considered when working with the problem. In our first example, if the universal set is defined by 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then only the natural numbers 1 through 10 may be used in the problem. This concludes our chapter section 1-1. We will continue with our discussion on sets in chapter 2.2.